Hello, geometry students. Yesterday we reviewed the Pythagorean theorem and we talked about 45, 45, 90 triangles. Today we're going to look at a 30, 60, 90 triangle and what that theorem looks like. Now, I had a mentor who taught me a song, and the song goes like this: 30, 60, 90, 1 root 3 and 2. And so I wrote that on your notes for you. And what that's relating to, you can go ahead and replace the 1 with an S, and you need to put an S with each one of the terms that I just put here. So let me just put that in a different color. S, S, S. That's just talking about the side of the triangle. So the angle 30 degrees points to the side that is the ratio of just one S. And the 60 degree points to the side that is the ratio of S root 3. And 90 degrees points to the ratio of 2S. So I'll sing the song to you again. And you should memorize this because it'll help you remember the pieces to this theorem. 30, 60, 90, 1 root 3 and 2. And I'll pause the video here so that you can practice singing that. And we're back. So let's apply this. And you can read about this theorem also. It's right here, what I just told you about. But it only works for 30, 60, 90 triangles. And in the try it, we have 30 pointing to 6. Well, 6 is the smallest of the ratios, so 30 points to 6, which is this S. And then I want to say my song, 30, 60, 90, 1, which is this, root 3, which is this, but I have to put the 6 in front of it because that's my side, root 3 and 2, and then 2 I have to put with my S, which is 6. So, right, because there's a 6 in each piece of it. 1 root 3 and 2, and each piece has a 6. So the S is equal to 6. The S root 3 is equal to 6 root 3. And the 2S is equal to 12. And so that's the 30, 60, 90. All right, now we just need to figure out what side is what. So which one is the PQ? PQ is this one. And this one is going to be PR. All right, we have another fun triangle, and we notice there's a root 3 with a 9. So 9 is going to be the smallest of the ratios. It's what the 30 is pointing to. So I'm going to put 9 here. And then I'm going to put 2 times 9 over here. The longest side is the 2 times it. And that's what the 90 is pointing to. All right, so what is UV? UV is equal to 9. And TV is equal to 18 because 2 times 9 is 18. And that is the 30, 60, 90s. And we'll do some practice with this today. For example 5, we have a 30, 60, 90 triangle. And it says Alejandro needs to make both the horizontal and vertical supports for a ramp. So horizontal is going this way, across. And the vertical support is right here, the AB going up and down. Is one 12-foot board long enough for both supports? This is like a real problem, especially with wood costs being so high. So we would need to figure out what the 30 piece would be and what the 60 piece would be. And we know that 10 is equal to 2s, right? Because it's a 30, 60, 90, 1 root 3 and 2 is the hypotenuse. So 2s is equal to 10 feet. So that means if we set it up like an equation, so 2s equals 10, and we divide by 2, then s would equal 5. So the short side would be 5 feet. And then the other side, so that's our s, which is very helpful to know if we know our s, because the other one will be s root 3, so 5 square roots of 3. Now I need to know what 5 square roots of 3 is, because we need to know if 5 plus 5 square roots of 3 is less than or equal to 12 feet. So that's my question. So let me use my calculator and figure out what 5 times the square root of 3 is. Let's see, the square root of 3 times 5 is 8.66 approximately. Uh-oh, if I add 5 to that, it equals 13.66. So that's a problem, because that would be greater than 12. So a 12-foot board is not enough for the supports, the vertical and horizontal supports. Let's practice writing that just so we can think about these vocabulary. For the vertical and horizontal supports. Sadly, he's going to have to buy another board, but maybe he could buy boards that are a little bit shorter than 12 feet, so it'd be a little cheaper. Like maybe he could buy 2 8-foot long boards, and that would work for his ramp. Some of you hopefully got to do a little bit of origami the other day. If not, I can give you a piece of origami paper. Olivia starts an origami paper crane by making the 200 millimeter diagonal fold. What are the side length and area of the paper square? Kind of like nobody cares, but we can still figure it out. All right. So remember that the 45, 45, 90s, so 45, 45, 90s are s, s, and s square roots of 2. So if s is 200, then, or no, I'm sorry, s is not 200. We're trying to figure out what s is. But the s square roots of 2 is equal to 200. So s square root of 2 equals 200. If I want to solve for s, I have to divide by the square root of 2. And in math, they do not like to have radicals in the denominator. So what I'm going to show you is something that will be useful in Algebra 2. But if we have 200 over the square root of 2, they'd like us to multiply, and this is a little weird, but multiplying by the root 2 over root 2 is really just multiplying by 1. Can you guys think about why that's just multiplying by 1? All right, cool. So what ends up happening is that in the denominator, a square root of 2 and a square root of 2 is like a square root of 2 squared. So the radical goes away, leaving us with 200 square roots of 2, but in the denominator, we just have 2. And we can simplify that further because 200 divided by 2 is 100. So 100 square roots of 2. And that would be the side length S. All right, so kind of write that in here, draw an arrow, that S equals 100 square roots of 2. And then they wanted to know the area. So area of a square is equal to S squared. So we'll put 100 square roots of 2, and we're going to square it. Well, I know right away that the square root of 2 squared is just 2. And so it's going to be 100 squared times 2, which would be 100 squared is 100 times 100, which is 10,000 times 2. So the area would be equal to 20,000 millimeters. Okay, so that answers the question of what was the side length. So the side length was this. And what was the area? And the area was this. And then turn your page. On this page, we have some triads, and they're a little tricky. So let's think about it. This first one, we have a 30, 60, 90 triangle. So let's do our song. 30, 60, 90, 1, and that's 1S, root 3, and 2, and don't forget to put your S's with it. All right, so we have the 60, and the 60 is S root 3. So how can we figure out what S equals if it equals 28? All right, so S root 3 equals 28. Well, to solve for S, we have to divide by root 3 because it will cancel that, leaving us with just S. So S equals 28 over root 3, and then we have to rationalize this. So we have to multiply by root 3 over root 3, which again is multiplying by 1. And that will give us the root 3's on the bottom become just 3, and then we have 28 square roots of 3. That is what S equals. And it's kind of ugly, but I don't care. I'm going to leave it like that. So that's S, which is this side right here. And then the 90 is 2 times that. So two S will be equal to 2 times 28 over 3 and square roots of 3. And 2 times 28 is 56. So 2S is going to equal to 56 over 3. And that is going to be our AB. All right, so this was BC. And this is going to be our AB. And I'll get a different color for that. And that's a little complicated, but if you think about the process, it kind of makes sense. So if we figure out S, then we just have to multiply it by 2 to get 2S. It was a little tricky that they gave us the S root 3 side. But that's how you do the 30, 60, 90 when you're missing sides. All right, this next problem is very similar, but instead we're dealing with 45, 45, 90, So that's S, S, S root 2. So that can kind of be a little chant for you as well. S, S, S root 2. And that is for 45, 45, 90. And so they gave us the long side. They gave us what 90 is pointing to. So 14 is equal to S root 2. So we have to solve for S. S root 2 equals 14. So we have to divide by root 2. And remember, when we divide by root 2, we have to rationalize it. So we're going to multiply by root 2 over root 2 to rationalize the denominator. Because it has to be a rational number, and the square root of 2 is not rational. So then we're going to have 2 on the bottom, because the root 2's square root of 2 times square root of 2 is 2. And on the numerator, we have this. We can simplify that further because 14 does divide by 2 evenly, so S is equal to 7 root 2. And that's our answer. It's kind of nice because both of these sides are the same in a 45-45. So they both equal 7 root 2. Now there's a little bit of a matching thing for you. So before you put your notes away, this kind of goes together. I know it doesn't look like it. But we have a triangle with a right angle, A, B, and C. And then we have another one that says it's a squared plus b squared equals c squared, but we don't have a right angle that's showing. Then we have a 45, 45, 90 triangle, and we have a 30, 60, 90 triangle. So can you match each one of those with, if that's the hypothesis, with the conclusion statement? So with these, can you match each of these statements with each of those pictures? And I'm coming around to check, and then we'll be finished with the notes.